Hey everyone, welcome back to day number 13 of the 30 Days of ML Challenge. And in this video, we'll be covering two lessons in the Intermediate Machine Learning microcourse in Kaggle, which are lesson number 4 called Pipelines, and as well as lesson number 5 called CrossValidation. Yep, so this is the Intermediate ML microcourse page. And in this video, we're looking at lesson number 4, Pipelines, which is a critical skill for deploying complex models with pre-processing. We are also going to look at lesson number 5 called cross-validation. I like to think of pipeline as a factory. So in a factory, you have different workers that work in a production line, and each worker have their own specialized skill, have their own sort of unique and specific tasks that they perform. So pipeline is, so think of it as like a big factory where you have you go from raw materials to the final product, and in that process you go through multiple steps in production. So for example, a worker will be responsible for imputation, dealing with missing values. The next one will be for encoding, and then the next one will be scaling. So you have all these different steps in a factory, in a pipeline that takes you from raw data to finally making predictions at the end. So you have all these steps that you can chain together in a pipeline, and so that is what's called a machine learning pipeline. So cool. So here we begin with a brief sort of introduction to what pipeline is. Pipelines are a simple way to keep your data pre-processing and model code organized. Specifically, a pipeline bundles pre-processing and modeling steps, and there are many benefits to using pipelines. So here we introduce to 4 different benefits. So first of all, we have cleaner code. So rather than doing each step step by step, we can actually chain and bundle everything together. So it'll help clean our code up a little bit better, which results in fewer bugs, which is our second benefit. It's also easier to productionize. So we can productionize a pipeline sort of like a package, so we can use it as a product. And last but not least, we have more options for model validation. So we'll learn more about model validation, specifically cross-validation, in our next lesson. But yeah, just know that these are the sort of the benefits that are involved with using pipeline. Cool. Because we've been doing this for a while, I'm just going to skip past, I'm not going to go ahead and just show you all the hidden code all the time, because they're pretty much the same. Because it's just splitting the data into training set and validation set. Here we have the first 5 rows of the training data. I think we're still using the house prices one, but that's okay. So let's look at step number 1, which is defining the pre-processing steps. So in order to create a pipeline, you have to think about what sort of steps you want to include in that pipeline. So it could be, for example, I mentioned whether you want to deal with missing values, you want to encode, you want to scale, what sort of models you want to use. So you want to think about all the steps that you want to include in that pipeline. So that's what step 1 sort of entails. So here we have 4 different functions that we want to include in the pipeline. So this is column transformer pipeline, which enables us to construct and build that pipeline. So these are the 2, I guess, steps we want to include. So first of all, we have a simple imputer, which, if you watch my previous video, is a function that enables you to impute missing values in the column, as well as the next step you want to include in that pipeline as well is called one-hot encoder, which is for one-hot encoding. So let's look at the steps here and sort of look at how we actually build a pipeline. So here we're instantiating a simple imputer into a variable called numerical transformer, and then we also have a pipeline. So here we're creating a pipeline for categorical data. So within that pipeline, there are 2 steps. One is called imputer, and the next one is called encoding. So for categorical data, we want to impute as well as one-hot encode, but for numerical data, there's no need for encoding, and so therefore for this one, we're only using simple imputer. All right, cool. So now that we have the steps for both numerical data as well as categorical data, we can combine these 2 steps into what is called a column transformer. So this transformer consists of 2 things. The first bit is for numerical columns, which we will apply numerical transformer to it. As for categorical variable, we want to apply categorical transformer to it, which is a pipeline, like I said, which consists of an imputer, a simple imputer, as well as one-hot encoder. All right, cool. So those are pre-processing steps. We can also include in the pipeline a model that we want to use to make predictions. So here we are using random forest regressor, which we've discussed plenty of times in the past couple of videos. and these are the parameters that we want to use for our model. So we've defined our model. Next, I believe this is the final step, step number 3. We want to chain everything together to create a pipeline, and then we want to evaluate how well the pipeline actually performs. So let's look at the metric here. So we are importing the metric called mean absolute error. So this pipeline is going to consist of the preprocessor. So preprocessor is this thing here. So preprocessor is going to deal with all the pre-processing steps with our numerical data as well as our categorical data. Once those data has been pre-processed, they're ready. We want to use the data that's ready to pass into the model and make predictions, which is the second part of this pipeline. So I guess just to summarize just quickly, our final pipeline will consist of a preprocessor, which will process all the raw data and perform imputation and encoding. And once the data has been pre-processed, we want to pass it into a model to make predictions. So as you can see here, this pipeline is chaining two steps into one. And what we can do with Scikit-learn is we can just treat the pipeline as if it was a model. So with a model, we looked at the 3-step process in Scikit-learn, which is instantiate, fit, and predict. So here we're instantiating it, we are fitting it to the training set, and then we're predicting using the features in the validation set. And we can calculate the mean absolute error. Beautiful. So I think what we just looked at is sort of chaining and how we can sort of bundle different functions together, pre-processing as well as modeling into one single step. That is a pipeline. We can then treat the pipeline as it was just a normal Scikit-learn model. So instantiate it or define it, fit it to the training data, and then we want to use the pipeline to predict the features in the training set. Beautiful. I hope that makes sense. We're going to move on now to the exercise for this lesson. All right, cool. Let's run the first cell for setting up. All right, setup is complete. Let's move on to step number 2, the second cell, and just create our validation and training set. I think that's ready. Let's go ahead and view the first 5 rows of our training data. All right, cool. So these are the functions, column transformer, pipeline, we saw simple imputer, we saw one-hot encoder. This is our model, and then the metric that we want to use to evaluate our model performance. Cool, I think everything's already done for us, which is handy. I think it's just a matter of running the cell. Let me just look at what we're doing. I think it's pretty similar. So here we have a transformer that's used for numerical data. We have a transformer that's used for categorical data. We have a pre-processing column transformer. And then we have our model, and then we want to build a pipeline that consists of the pre-processing steps, which is this one. Once our data has been pre-processed, we want to run our data into the modeling, which is a random forest regressor, and then we want to fit, predict, and calculate the mean absolute error. So pretty straightforward. Let's just look at the mean absolute error. So it's $17,861. The code yields a value around 17,862 for the mean absolute error. In the next step, you will amend the code to do better. Cool. So step 1, we want to look at how we can improve the performance of our MAE, pre-processing for numerical data. Now it's your turn. In the code cell below, define your own pre-processing steps and random forest model. Fill in values for the following variables. So we can sort of change this to, instead of most frequent, we can change it to constant. I'm just looking at the solution. What else can we do? Number, yeah, let's just go ahead and run the cell again and see if our result improves. Yep, so it improves. Next, we want to generate test predictions. So our pipeline is called my pipeline, and then we just want to use my pipeline to predict the test data. So test X, is that it? X test or test X? I think it's X test. My pipeline dot predict. I forgot my predict. Spelling mistake. All right, beautiful. All right, so this next cell is saving our predictions into a pandas data frame, and then from a pandas data frame into a CSV file, and then submit it. So I'm gonna skip this step and yeah, just move on to our next lesson. You can do that in your own time. We're gonna look at lesson number 5, which is called cross-validation. All right, so in this tutorial, we will learn how to use cross-validation. So essentially what cross-validation is, yeah, feel free to go through all this when you have the time. Yeah, so this is sort of the visual aid, also the visual representation of what's going on. So under the normal scenario, we would just have one single experiment, right? So if we think of just a normal scenario, we would have, say for example, we would have 80% of the training, 80% of our original data as our training data, and then we will retain the remaining 20% for testing. And that's pretty much it. But in a cross-validation scenario, we would have, well, depending on how many times you want to cross-validate. Here we are cross-validating 5-folds. So this is called a 5-fold cross-validation. So we are replacing. So we're constantly changing the validation set 5 times. And then we're taking sort of the average of our model accuracy. So as a result of that, rather than relying just on one single experiment, we're repeating that experiment 5 times and taking the average across the 5 experiments. So for small data sets with extra computational burden isn't a big deal, you should run cross-validation. But if you have a large data set, which will sort of take a long time, cross-validation set might not be necessary. And the reason is because if you have a large data set, the chance that you might fall into the risk of your model achieving a good result by chance is actually very low. I hope that makes sense, and I hope I'm conveying the right message. But essentially, this is pretty much the stuff that we just looked at, right? We are creating a pipeline that consists of a pre-processing step, and in that pre-processing step is a simple imputer. Once we run our data through that simple imputer, we want to use a random forest regressor. So this particular pipeline consists of two steps, one pre-processing step and one modeling step. And then what we can do is use a function called cross-val score, which calculates the cross-validation score for a particular model, a particular pipeline. Yeah, so here we are calculating the cross-val score of our pipeline. Here we're doing 5-fold cross-validation. And so here, if we scroll back up, this is pretty much essentially what we're trying to do. So we're setting aside a validation set. We're using the training set to train our model, and then compare the model predictions with our validation set. That will be our first iteration, our first experiment. We move on to our second experiment where we use a different subset of the data as our validation set, repeat the whole process, training, validate model accuracy, move on to the third experiment, fourth experiment, and the fifth experiment. So we're repeating 5 times the whole process altogether. And in each step we are saving the mean absolute error from each of the iterations. So here we can see we have 5 mean absolute error values, 1, 2, 3, 4, 5, from each of the 5 iterations pretty much. And here within the cross-val score, there's an argument called scoring. So this tells what sort of metric you want to calculate, because we're interested in mean absolute error. So this is the value that we have to set for the scoring argument. And then and then you can take the average. You can take the average across these 5 values. So you can sort of, if you want to check the value, you just sum these 5 values up and divide by 5. You should get this particular value here. Cool, so that's pretty much the conclusion. So using cross-validation yields a much better measure of model quality with the added benefit of cleaning up our code. Note that we no longer need to keep track of separating training set and validation set. Everything's bundled together in that single cross-validation step itself. That all we need to do is specify how many times we want to iterate through that process. Whether it's a 5-fold cross-validation, whether it's a 10-fold cross-validation, it really depends on how big your data set is. But essentially that's the sort of overall idea of what cross-validation is and why it's important that we do it. With that in mind, let's begin the exercise. All right, so let's run cell number 1, which is just for setting up, as usual. All right, cool. And then we have cell number 2, which is just another cell for setting up. All right, I think that's ready. Let's look at the first 5 rows of our features. So these are all our features. Let's scroll down. So here we are defining our pipeline, which consists of a simple imputer as our pre-processing step. And then we have a random forest regressor as our model of choice in our pipeline. Cool. So our pipeline has been defined. We can now use cross-val score and calculate the mean absolute error after performing 5-fold cross-validation. And we're taking the mean from those 5 iterations. All right, so step number 1, we want to write a useful function. Begin by writing a function called getScore that reports the average over 3 cross-validation folds, the mean absolute error of a machine learning pipeline, the data in X and Y to create folds. We want to include a simple imputer as our pre-processing step, as well as a random forest regressor as our model. The n estimators parameters applied to getScore is used when setting the number of trees in the random forest model. Cool. So we have a function here, and this function takes in one argument called n estimators, and this particular value is going to feed into the argument in our random forest regressor. Yeah, so let's just go ahead and replace all of this with our function. So first of all, we need to obviously create our pipeline. So I'm just going to take a peek at our previous our lesson. So I think I can just like copy this to save some time, because the pipeline is almost the same. So here we are creating a pipeline, and then so instead of setting 50 as a fixed value, we want to pass in n estimators, which will be fed in from the user. So whatever value that's specified here will flow into here. And then we want to return the average. So I can copy this as well. So let me just go ahead and paste it here. So scores, because we're running three-fold cross-validation, we can replace this with 3. And then we want to return scores mean. Return scores dot mean. So that's pretty much it, I think. So let's check our answer. Correct. Beautiful. Step number 2, we want to test different parameter values. So here we want to use the function that has been defined in step number 1 to evaluate the model performance corresponding to 8 different values of the number of trees in the random forest. Store your results in a Python dictionary called results, where results I is the average MAE returned by getScore I. So we probably have to like loop through this and then pass in the values into our function and get the average MAE. Okay, I think I know what to do. All right, so let me just pretend I didn't see the answer. I'm trying to replicate it in my head. See if I can replicate it. So we're creating a dictionary, an empty dictionary, for I in range 1 to 9, because range it's inclusive of the first element but exclusive of the last one. So we're actually going from 1 to 8. And what we want to do is we want to do results dot 50 times I is equal to get score I. Get score 50 times I. It's probably going to take a while because we're looping through 8 different estimators. And random forest probably takes a while. And the fact that we're doing 3-fold cross-validation, that's going to take even longer. Yeah, let's just wait for the cell to load. I'm going to cut this whole part out so you can skip to the very end when the output actually comes out. All right, cool. So I wonder if we like have a look at the results. What do you think we'll see? Let's have a look at results. So here we have a dictionary that consists of 8 elements. So the key represents the number of estimators in the random forest regressor model. and their corresponding value is the average MAE. And then this is just gonna plot, I think, for us to visualize the mean absolute error. Cool. So this one, yeah, so as we can see, this is the lowest point. The number of estimates that give us the lowest mean absolute error. So this should be 200, as we can see from the graph, it's 200. Let's just check our answer, correct. Cool. If you'd like to learn more about hyperparameter optimization, you're encouraged to start with grid search, which is a straightforward method to determine the best combination of parameters. Yes, so GridSearchCV is another function in the Scikit-learn library. What GridSearch does is you need to specify the different values that you want to try for different parameters in the model, and GridSearch will allow you to find the best combinations of those hyperparameter values. If you're interested, yeah, just Google GridSearchCV. I might put the documentation in the video description as well, just to help you guys. Yeah, I think that pretty much wraps up this video. So in this video, we looked at two lessons. We looked at pipelines, which we know it's a method of chaining multiple steps into a single step. And we just covered cross-validation, which is a method to test your models in a more accurate way, where we iteratively perform the training and validation part of the process in order to get the average value across those different iterations. All right, cool. I hope you learned something from today's video, and I hope you're enjoying the series so far. Please subscribe to my channel. It'll mean a lot to me. Drop a like on this video as well, just to let me know that you're enjoying the video series, enjoying the way I'm explaining to you guys. Yeah, I'm really having a blast putting out these videos for you guys, and I hope you're feeling the same way. Yeah, I'll see you in my next video, where we'll finish up the final two lessons in intermediate ML, and once we finish those two lessons, we're gonna move on to the actual competition, and sort of apply the knowledge and skills that we've covered from this past 2 weeks into a real project, and let's see how we go with that. All right, that's a wrap on this video. Subscribe, drop a like on this video as usual, and I'll see you in my next video. Peace.